Hey guys, welcome. Today in the first chapter 12 video we're going to see something a little bit different. I really don't know how long this is going to take. There's no math whatsoever involved, or at least no quantities that are involved with today's lesson. Chapters 11, 12, and 13 together are kind of an interesting unit. We started, and you've got in bold at the top of this slide, the title Simulations with Random Numbers, then the arrow to probability. Simulations with random numbers, I've been telling you guys in both classes a little bit that the simulations that we're doing are going to be kind of not foreshadowed, covered, I guess. They're going to be extended upon when we get to probability in chapters 14, 15, and 16, which one of my favorite sections of the book because it's actually mathematical. Woohoo! Today we're going to look at surveys. We're going to talk about surveys some. We will get to, in chapter 13, we'll get to experiments and observational studies both. Surveys, experiments, and observational studies, those three ideas lead to inference testing, which is powerful. Inference testing is maybe some of the most powerful stuff you can do in statistics. Surveys, experiments, and observational studies all focus on, and this is why they foreshadow inference testing, they all focus on learning about a large group, which you would call a population. Think about, I'll use the word population in a way you're familiar with. If I want to learn about the population of Yorktown, I might care to learn about what's called a parameter of interest, the thing regarding the population, all the students who attend Yorktown together, such as the average height of the students here at Yorktown, where the average height of the students here at Yorktown is the population parameter, the population being all the students who attend, and the parameter being the thing, the fact that is true for that population, in this case, the average height. Okay? And with surveys, you can learn about the average height of all the students here at Yorktown without having to go to every single student. If we went to every single student, Mr. McCormick actually dropped this statistic recently. I was talking to him just a few minutes ago. I think he said there were like 897 students here at Yorktown. If I wanted to learn about every single student here at Yorktown, all 897, that would be me conducting a census. So I could, if I really wanted to, if I wanted to make sure that I got good data, go to every single student, knock out a block of time for every student within a particular window. I wouldn't want to take years to do this because people grow with time. Freshmen are not as tall, or excuse me, are taller as seniors, obviously. Within a short period of time, I could look at the heights of all the students here at Yorktown. Well, that's a tedious thing to do to make sure that I'm getting everybody. And surveys acknowledge that a census is a tedious thing to do, and it can be both time-consuming and expensive. Okay, the logic behind a survey, I think, is best understood in terms of, think about kind of I'm sure you guys have all watched some sort of movie, some sort of TV show, where you've got like the sort of the buxom, matronly, older female chef who is stirring up like a pot of soup, okay? And this chef, who really knows her stuff, wants to learn to see whether or not this soup is ready. She's trying to, maybe it's the saltiness. That could be her parameter of interest, the saltiness of the soup, where the population would be every little morsel or every drop of soup in her pot. Okay? Well, when you see on TV, in the movies, someone trying to learn about this pot of soup, you don't see them drink the whole pot of soup or consume the whole pot a la like a census. Instead, you see them take maybe a ladle or a big spoon into the pot, stir it up, make sure that it's evenly distributed inside the pot, and then they'll take a sip from the spoon. And that'll give them a sense of whether or not The saltiness, if that's the thing that they care to learn about, is appropriate for the whole pot of soup. Okay, that's the logic behind a survey. It saves time, and you can actually get, because the census learning about everyone in the population, whether or not the population be the pot of soup or the population be every single student here at Yorktown, conducting a census, it takes too long and it's too easy to miss people. Surveys are actually preferred. They don't look at everybody. They select people just like the pot of soup at random. Okay, you're selecting just I'm going to call it a subset, a smaller set of the whole population, a subset of the soup with the ladle. Okay, but just like with simulations, that selection process is randomized. Okay, you're not. And that goes back to think in terms of this matronly older chef who really knows her stuff, stirring the whole pot up before she takes a sip from the ladle. Okay, she's making sure it's distributed, yes, so that she doesn't get any bias, any skewedness to term drop from earlier in the semester. She doesn't want her sample and her survey of the soup to be skewed. She's stirring it up so all the soup in the pot will be the same. And then she takes her sip. Okay? But when she's stirring it up, that makes it random. Okay? What she gets in the ladle is going to be random. Now, obviously, you may have seen a TV show or a movie where she's not just getting it random. Maybe she wants to know whether or not the meatballs in her stew or something are particularly good, in which case she's obviously going to select the meatball. But that's sort of an aside. That's a tangent. Okay? So, but with this analogy of the soup, there are three important things that are happening with this chef when she's trying to learn about the saltiness, if that's her parameter of interest, for the soup, if that's her population. Again, first, she's not looking at the whole thing. She's just looking at a small piece. Secondly, she's randomizing. Okay? She's drawing with a ladle just a little bit of the soup, but she wants that to be a random selection of the soup. Okay, we're not choosing who to include. Think about it. Go back to when I first started talking about trying to learn about the parameter of interest, average height for the population Yorktown High School students. Okay, it's actually incredibly tough to select on your own which people you're going to include in your survey to make an estimate of the average height of the students here at Yorktown. I'm not going to go to the fourth block white day statistics class and try to average the height there, because especially there's some really freaking tall guys in the class. You've got Riley Neal at 7'53", I don't know how, 6'5" or so. You've got lots of guys above 6 foot. So trying to determine what would be a fair way to get a sense of the height for everyone in the school is hard to do unless you make a random selection, unless you choose students at random. Okay, so you're choosing just a piece, you're choosing a subset, you're randomizing, and the third thing that's important, actually, think in terms of the soup analogy again. I know I keep going between the height and the soup thing, but hopefully it gets the point across, because surveys involve some just understanding of the logic. I think if you can get the logic behind surveys, then branching out and understanding the pieces, the details of the surveys is easier. Okay, so third thing is that if the chef cares to learn about a pot of soup that is a gallon full, or a pot of soup that is 1,000 gallons full, that doesn't matter in terms of how much soup there is in all. The population size doesn't matter when she takes a sip, because if all of the soup is well mixed, if she has taken her ladle, her big fat spoon, and she's stirred it up before she takes a sip, then the sip should look like the whole. Okay, the drink of the soup that she's taking from her ladle should be a strong indicator, it should strongly resemble what the soup looks like, regardless of whether or not there are 1,000 gallons of soup or if there's a single gallon of soup. Okay, so again, three things. taking a subset, it's random, and it's really about the size of the set, not about how much soup there is in all. Okay? All right, so to learn about a characteristic of a population of interest, we have two options available to us. We can either learn about the characteristic of interest by interviewing every person in the population, that is a census, or we can take a sample from the population to estimate the characteristic of interest. Okay? If we learn about the characteristic of interest from our sample in such a way that either A, precludes people in our population from being included in the sample. Okay, let's go on to B, and then we'll talk about examples of each. Or B, doesn't give equal likelihood of selection for our sample to include everyone in the population, then our survey design is biased. Okay? Bias is something that we need to avoid. So, let's say that, for instance, I've got a good example. Let's go back to the population is the Yorktown High School student body. The parameter of interest is the average height of the students here at Yorktown. Let's say that I wanted to take a sample by sending to everyone's ELC teacher a little pamphlet that says just simply, please help fill out this survey. It has a space for you to fill out your name, and it also has a space for you to fill out your height. And then the ELC teacher gets that back to me, Mr. Shelton. Okay? Well, that's a problem if that's how I've designed my survey, because I have just precluded, or I have omitted the possibility of even getting people in my survey. Anyone who doesn't have an ELC is suddenly omitted from the survey, when if I care to learn about the whole student body, that's a problem. Maybe the group of people who don't have ELCs, if a bunch of people have AP release, I could accidentally be excluding from our survey a lot of juniors and seniors who are naturally going to be taller than the freshmen and sophomores. Okay? So there's a quick example of bias resulting from omitting people in your survey selection process. Okay, B here doesn't give equal likelihood of selection for our sample to include everyone in the population. So an example of that I'd come up with, let's say that we care to learn about whether or not the people who attend the YMCA, that'll be people obviously who have Y memberships. The people who have Y memberships and attend the YMCA, let's see if we care to learn about whether or not their household whether or not their household uses an elliptical. Okay? Well, if all that I do is I go through the list of people who have YMCA memberships, let's say there are 1,000 people who in our computer database have YMCA memberships, and I go through and just choose at random from those 1,000 people 50, and those 50 people I send home a pamphlet that I get back that asks them if anyone in their household uses the elliptical. There I have unfairly weighted the households, okay? Because if I care to learn about how household to household differs, think about it. I am a family of one, so to speak. I've got, if there are 1,000 people who attend the Y, I might be chosen at random as one of the 50. But if you have versus, think of a family of 5. If you're trying to learn about whether or not anyone in the household for a family of 5 uses the elliptical, they are 5 times more likely to be included in the survey because there are 5 people in the household. Okay, 5 people who are YMCA stakeholders. They have YMCA memberships in the household. So I've given the likelihood for that family of 5 to be 5 times greater in the survey than for me being a single person. These are 2 things to avoid to make sure that your survey is not biased. Okay? Everyone should have an equal chance of being in the survey, and you need to, as best you can, try to make sure everyone in the population can be included in the survey. Okay? Sampling frame. This term last year really threw remember 3 or 4 students asking about this a lot. It's the group of people who can be selected from the population for the survey. We want to make sure our sampling frame doesn't exclude people in the population, that each person in the sampling frame has equal likelihood of selection for the survey. So a sampling frame is the sampling frame, if you're going with the soup analogy, so you're trying to learn about a pot of soup, you want to learn about its saltiness. If what you're doing is you're stirring the soup up before you pour, or not before you pour, but before you dip the spoon in and take a sip from the spoon, the sampling frame would be the whole pot, because any of the soup in the pot can wind up in the spoon if it's been stirred ahead of time. Okay, that would be a good attribute of our survey design, because it's possible to have any little morsel of the soup in the spoon. That's good. Any soup can be included. If, on the other hand, you go to that bad example I'd come up with for surveys earlier, where all you're doing is sending a pamphlet out to students, to their ELC teachers, and asking for name and the height of the student, the sampling frame there would just be students in Yorktown who have an ELC, where the population of interest is larger than that. The population of interest would be, yes, all the students at Yorktown have ELCs, but also all the students at Yorktown who don't have ELCs. So that would be a biased survey design. The sampling frame, if you're designing a survey well, needs to be the same size and include the same people or things that the population includes. Okay? All right, let me check my time here because I know I'm being wordy. 16 minutes. Okay. All right. So we're going to go through a few examples here. We're going to talk about, I think there are 6 in all, examples of bias. These are things that you want to watch out for, look to avoid. We'll introduce the terminology as we go through. Okay, so suppose I anonymously tweet my students at random directly after school hours to see how they feel about math classes. Let's say I want to know whether or not they like their math classes at Yorktown. How does this survey strategy introduce bias into my data? Well, hopefully you're seeing here that if my population of interest is all the students at Yorktown who have taken or are taking math classes, well, my sampling frame is not equal to my population size, because not everyone has a Twitter account. Now, obviously, a lot of you guys do. Most do. I do not, for instance. So if I was a student here at Yorktown, I would not be included in the sampling frame because I'm not available for selection in the survey because I don't tweet. Okay? This is called undercoverage. And it again results from when your sampling frame size is less than your population size. You have accidentally or perhaps intentionally omitted people from the survey. Okay, second one here. Suppose I poll willing students at random on a college campus, asking them about their feelings on a scale of 1 to 10, 1 being very upset with, 10 being very happy with, the backwardly conservative, egotistical Mitt Romney. How does this survey strategy introduce bias into my data? Well, you've got in parentheses here 2 things that are abbreviated. The first thing that you have, hopefully you picked up on this wording here, willing students, okay? That introduces voluntary response bias. And that's a problem for the following reason. If all we're doing is getting information from people who want to be included in the survey, it's totally possible that the people who want to be included in the survey would have very different feelings about Mitt Romney than the rest of the population at large. Okay, so my population might be students on this college campus, and again, the parameter of interest would be their feelings for Mitt Romney. So there's some overlap here. Voluntary response bias is from the fact that, again, I'm only getting data in my sample from students who care to be included, and thus the results from those people who want to be included in the survey may look different from the rest of the people. It would be like the chef who really knows her stuff just letting the pot of soup boil for a while, all the heavy stuff or dense stuff sinks to the bottom of the pot, the light stuff in the soup floats to the top, and she just skims off the top to learn about the soup. That would be the same thing as the voluntary response bias in some sense. You've not well mixed the soup or the student body for selection here. Okay, that's a problem. Second thing that's occurring here, and this one's I think a lot more clear, is the wording of the question. Backwardly conservative, egotistical Mitt Romney. Okay, that's response bias. I have injected my own bias into the survey process, which obviously it taints, it affects in a negative way the sort of results that we're going to get. If we care to get true results about what the whole population of students on this college campus believe, that is not an appropriate way to ask the question. Okay? Now again, what I want you to think of here is the fact that these two obviously linked, especially, and I'll just go off with the second example. When you've got the voluntary response bias, you are automatically guaranteeing that your sampling frame, the people who could be chosen in your survey, is not of the same size as the population size, because people will not respond. So they're not available to get responses from when you are only looking for willing respondents, okay? So there's overlap between these terms of bias. And more important than identifying, oh, is it exactly this type of bias, is identifying whether or not the type of bias you want to call what you might see as a problem in the survey design, whether or not that's just the case, whether or not that's true. I would take, for instance, on the second problem that you had under coverage because of you're only selecting the willing students to respond. Okay, I'm going to check the time again here. All right. Suppose ESPN wants to track how many people watching ESPN believe Kobe Bryant should remain with the Lakers. They show in a caption a phone number on the screen that the audience can text their response to. How does this survey strategy introduce bias into my data? Well, what they have done, and here too, you've got let me look through the second sentence again here real quick. They show in a caption a phone number on the screen that the audience can text their response to. Okay, this we call convenience sampling generally. And thus, there is convenience sampling bias that results. They've really not done any legwork. They're expecting the people, the population of ESPN viewers to respond and basically do the survey for them, in a sense. And there, too, you run the same risk of voluntary response bias that you did in the second example. So notice again, there's a lot of overlap. They're not well-defined terms that we're using, because convenience sampling bias does not refer to something that is exclusive to convenience sampling bias. It overlaps with voluntary response bias. If you're sending this phone number out that people can text back to, only those who are voluntarily going to respond to the survey will respond to the survey. Okay, so there's also under coverage. You're not going to have everyone in the sampling frame, that is the people who could be a part of your survey, actually in the survey. It's under coverage because everyone who will respond to the survey is not necessarily the same group of people as the population you care to learn about. I think that's better said. All right, so lots of different biases going on, lots of different problems we've seen with survey design so far. Okay, let's look at three more here real quick. Suppose I want to see if people favor regular exercise. I decide to survey people at random from the parking lot of the YMCA. How does this survey strategy introduce bias into my data? Well, let's back up and let's say additionally that I want to see if people favor regular exercise within Yorktown specifically, and then I decide to survey people at random from the parking lot of the YMCA. Okay, so now I think that's a little bit clearer. The population is Yorktown. The sampling frame, therefore, is anyone who is in the parking lot of the Y while I'm conducting the survey. So how does this strategy introduce bias into my data? Well, clearly it is, and you could call this a couple of things. This certainly sounds like convenience sampling. I'm not really reaching out to the citizens of Yorktown to learn about whether or not they enjoy regular exercise. I have an example of under coverage here, where my sampling frame, again, is just the people who will be in the parking lot of the Y while I'm there, versus the population size being anyone who would live in Yorktown who could go to the Y, that's much greater, obviously, than just the group of people who will be in the parking lot. Okay, and I don't know that voluntary response bias is a problem. I don't know that response bias is a problem because I've not been given the problem. I've not been given the question to ask, and I don't know whether or not I'm following through with people aggressively. If I'm making sure that if I'm choosing people at random and I follow through aggressively to make sure I get response from them, then voluntary response bias may not be a problem here. Okay, the owner of the Star Press would like to know how he or she can improve the quality of the paper for its readers. He or she decides to place a flyer in Wednesday's newspaper, which respondents can mail back to the Star. How does this survey strategy introduce bias into my data? Okay, again, I think this is probably most akin to the Kobe Bryant ESPN example on the last slide. Here you have convenience sampling bias. Where, in effect, you're only going to get responses from the people who care to respond. Okay? So that's a voluntary response bias. You're only going to hear back from the people who care enough to send information back to you. In general, I don't know. I don't know if this is on laziness or because of laziness on my part or what, but those sorts of surveys I almost never respond to when I get those things in the mail. Partly because I worry about how the survey is conducted, partly because I don't know how the data is being used. I'm leery about giving that sort of information out because I guess I get concerned that it's just being used to learn about me as a demographic for business purposes. And that's not, I don't know, that's not something I want to contribute to in my free time. But that's kind of a tangent. All right, suppose you want to determine how likable you are to dogs in the local pound. You're looking to see for how many seconds dogs selected at random in the pound will wag their tails when you greet them. Forgot about this example. Unfortunately, you've just cuddled some lovable cats, but they're hated by the dogs in the pound. How does this survey strategy introduce bias into the data? Well, I don't think this is the clearest example ever, but it always makes me laugh when I read this one. Well, okay, so if you want to know how long the dogs will wag their tail when you greet them, perhaps as a way of determining whether or not they like you, and you've just cuddled some lovable cats, then clearly it is closest to the example in the middle here where we said that we thought Mitt Romney was backwardly conservative and egotistical in the asking of how people feel about him. Here too, we're trying to learn how the dogs feel about us, but we've just covered our scent in something that dogs are generally not fond of. So we've got another example of response bias. We have set this up to give us non-neutral answers. It's only natural that the dogs will not be particularly fond or familiar with us. Okay? All right, so we're going to talk about some survey strategies that are a little bit better. And again, I want to check my time. I don't want to take too long for this. I know I'm being wordy. 29 minutes. Okay, I think we can get this done in about 35 minutes or so. We'll see. We'll see. Let's talk about survey strategies we have that are good and give us unbiased data. Each have slightly different applications, and knowing when each sampling strategy would be appropriate is part of becoming a competent statistician. Yeah, this just comes with experience. So the simplest survey strategy we have is a simple random sample, where every individual in the sampling frame, again, the pool of people we can choose from to gather our data for the survey, has an equal likelihood of being selected for our sample. If, for instance, I wanted to know how tall my students are, on average, I could pair them with a number between 1 and 130-ish and select a subset of that sampling frame, 20 for instance, and record the height of each of these students. Okay, what do I mean in parentheses? There was a lot of information that was packed there. Okay, I first, right here, identified two things. I identified both the population. That was last year's 130 students in all. I have more this year. I have more like 150 students at this point. So I identified the population and also the parameter that I care to learn about, how tall the students are, on average in this case. Okay? And I describe here the method through which I can select them at random. Again, because you're not going to be able to, going back to the chef analogy, put together all the items that you think represent what the whole soup pot looks like by putting a little bit of water, a little bit of tomato juice, a little bit of, I don't know, broccoli, whatever that's going into your soup in the ladle or in the big spoon yourself. That needs to be, the soup needs to be stirred up, and you need to select the soup with the spoon at random. Okay? So I'm pairing all the students with a number between 1 and 130. Think back to how you guys ran your simulations with a randent in Chapter 11. And then I select a subset of that sampling frame, 20 for instance, so my sample size is 20. I have a sampling size of 20, there are 20 students being selected, and record the height of each of these students. Okay? That is a simple random sample. Everyone can be included in the survey, because my population is just the 130 students, and I've paired every student with a number. I could use randint 20 times, or at least 20 times. I could use randint at least 20 times to generate numbers between 1 and 130, ignoring repeats, because I'm not going to record one person's height 2 times, and that would be a sample. A census would look like me going to every one of the 130 students, recording all 130 heights. Obviously, it takes more time. This survey method is easier. Okay? In a stratified random sample, the population I wish to learn about is cut into homogeneous groups. That means same. They look similar. Then individuals are selected at random, with the random individuals I choose from each group being proportional to the size of that group compared with the total population. Okay, let's back up. Individuals are selected at random, with the random individuals I choose from each group being proportional to the size of that group compared with the total population. If, for instance, I wanted to know how tall my students are on average, I could cut them into 2 groups, boys and girls. If girls account for 70 of my 130 students and boys account for 60 of my 130 students, and I want a sample size of 13 students, I could choose 7 girls at random because they're 7/13ths of the population. Now, where that fraction came from is simply 70 divided by 130. Okay? And I choose 6 boys at random because they're 6/13ths, or 60 divided by 130 of the population. Okay? So with stratified random sampling, it's a useful method when you suspect that within the population of interest, if again the population of interest is the 130 students, that there will be clear differences within those within that population. And that's why stratified random sampling would be an excellent method to use to learn about the heights of students here in my classes. Because, sure, boys and girls are absolutely different heights. Guys' heights continue to climb. Last time I had heard 5'10" was the average, but between the fact that I think that we have culturally sexual selection for height, it tends to be. That's not my bias coming out. I'm not, and that's not my preference either. I'm not trying to say that, but just factually, we as a culture are selecting for taller people. So we're growing. Also, our diets continue to improve, even if that's marginal improvements with time. We are still growing as a group, but Guys tend to be 5'10 plus. Girls, I don't know, 5'6", 5'5 plus, something like that. And so I've cut my sample size of 13 into two ratios. Where those ratios keep the proportion of boys and girls in the population. Keep the proportion of 7/13 for girls and 6/13 for boys. Okay? And that way, what that allows me to avoid is a sample size of 13 where all I get are boys. And my estimate of the actual height of the 130 students I have is too great. Or if I got all 13 girls, I'd run into a similar problem, only my average would probably be too short. Okay, so that way I'm being fair to the whole population and including my two disparate or different groups. Okay, cluster sampling splits the population you care to learn about into similar clusters and randomly selects one of these clusters to be used for your sample. If, for instance, I care to learn about the average height of my students, and let's assume that each class I teach is for seniors, split fairly evenly between boys and girls, I could choose one of my 6 classes to serve as my sample. Now that's a little bit contrived in this case. That's a forced example. So cluster sampling works if, and I would say that, I would lean to saying that is less commonly used than stratified sampling. Let me go back here real quick. Yeah, than stratified sampling. Cluster sampling is where if you've got your population divided in such a way that there are groups that should look like what the population looks like, then you can use one of those groups as a sample, and that's what we've done here. Think about it, think in terms of the chef example. Let's say that we had taken, let's say the chef she had prepared her soup, she put it in like 5 different Tupperware containers, and she was going to send that out to 5 of her friends just to be friendly, just be kind. But then she realized, oh crap, I forgot to check to see whether or not the salt level of the soup was appropriate before sending the soup out. Well, what she could do, if she had stirred the soup up well before she poured it into each of those 5 Tupperware containers, she could simply test one of the 5 Tupperware containers, because they should all have the same mixture between the 5, to see whether or not she needs to add salt. She shouldn't have to check all 5, as long as the soup is evenly mixed from container to container. Okay, similar idea here with the cluster sampling for the classes. What I was saying is, if pretend, hypothetically, the 130 students I had last year were strictly seniors, so there shouldn't be any differences in height accounted for by age differences, and let's say that each class was split evenly between boys and girls, I could simply choose one of the 6 classes that could serve as the sample that I would use. Okay. All right, so there's cluster sampling. Systematic sampling is interesting. It goes through systematic, and it does what's called incrementing. Let's say if I've got the same 130 students, and I want a sample size of 26. Okay, what you do is you take your 130 students in the population, divide by the sample size you want. In this case, that gives you 5. That is the number that you will go in order for the students. So what I would do is, first of all, I would number all of the 130 students from 1 to 130. Okay, and I don't have to do that randomly. Okay, we'll get to the random element here in just a second. But I could say, last year I could say, I don't know, Quinn was number 1, I could say Brooke was number 2, I could say Chandler was number 3, I could say Barami was number 4, blah, blah, blah. Just go through and number each of those students from 1 to 130, and then I would first select, using the random function on your calculator, a number between 1 and 5 to be the first student selected in my sample size of 26. Okay, so let's say I get a 3, I guess that would be Chandler. Chandler would be the first person I would go to for my sample, and then I would add 5 to that. I would check the 3rd person, Chandler, then the 8th person, adding 5 again, then the 13th, then the 18th, then the 23rd, then the 28th, etc., up until the last number I can get before 130, okay? And that would be my random sample. Why is it random? Because Chandler was selected at random, okay? Then from there, by adding 5, these guys have also been chosen in some sense randomly, because whether or not they're included in the sample is determined by that random selection of the first person. So that's a fair way to sample, because anyone can be included in this survey. Okay? If I had chosen one, who did I say that was? Quinn. If I had chosen Quinn, then the 6th, the 11th, the 16th, the 21st, the 26th, etc. persons would have been included in my sample. If I'd chosen 2, I would have gone 2, 7, 12, 17, 22, etc., etc., etc. Third, we showed. Fourth would be 4th, 9th, 14th, etc., etc. So anyone could be in the sample, and they all have an equal likelihood of being chosen. In this case, there are 5 different groups of people I could include in my sample. So everyone in the school, not the school population, but the student body I teach, would have a 1 in 5 chance of being chosen, or a 20% chance. So it's fair in that regard too. Okay, last but not least, multi-stage sampling uses a combination of your simple random sampling, stratified random sampling, cluster sampling, or systematic sampling. Okay. Hope you guys took good notes on this. I don't know why I'm saying that so late, but I hope that you did. This is a wordy chapter, and there's not a whole lot I know of to show you visually that I can draw. But I will explain problems